Nothing.
Nope.
I didn't
Wait,
get
what
any
email?
email.
No email?
Something like just now?
So when I
You never hit
described
send
the,
when talking.
I didn't send.
I
No, I
think
did.
it's pretty fresh.
When did you send it?
It's a minute, but 15 minutes ago.
Oh, okay. I haven't checked my email yet.
Oh, then no, I
I
didn't.
haven't gotten it.
Had an amplitude. I don't remember what the amplitude was.
E naught.
Oh,
No, you never.
No,
You
it's
never.
not.
You never sent it because I don't have it.
Yeah,
I
I
have my
don't
phone.
Which
why didn't
problem?
it?
Did you send it? No, you
The
can't
last
send it
problem?
physics one. I would still have gotten it if you sent it to physics one. So
Well, I'll tell you, and then I'll email the rest of the students.
Is it the last
Is
problem?
sign K0x defined from plus 3 lambda 0 to minus 3 lambda 0.
Yes. That's problem 52.
All right? These are constants. Lambda 0 and K0 are constants, not variables.
You get a very screwy answer if that's not true.
Yes.
you get integrals that Wolfram times out on immediately.
Yeah, you're not allowed to have a
I figured
spatial wave
something-
function that could, yeah, that would be messy.
Well, if you have a spatial wave function that depends upon
Okay.
A,
But you can, but it's supposed to be f of x, not f of k and x. You're freezing it at a moment in time, and you're asking, what does f of x look like?
it gets on.
So there's no k there.
That's common.
And then that's also equal to the integral barring factors of pi. A of k. I know it's going to be a sine transform x. dk.
You want to close that?
That's also equal to that, all right? And A of k, barring factors of pi, is equal to the integral of f of x
I have shots.
sine kx dx.
The first one's just missing 1 over pi. We don't even need that one.
I took care of it.
We don't even need the regular transforms.
Okay. I'm gonna give you a little bit of an answer as to what the answer is. I'm not gonna do it, right? And there's gonna be more to it, but I'm about to tell you. But if you were to plot A of k as a function of k, it would look like this. Centered at minus k0 and k0, right? And one of those sides would look like sine of k minus k0 oh yeah, sorry, yeah, times a constant. I'll just put constant in there because there might be something to do with 3 lambda. Okay. Divided by k minus k0 times a constant. It's the same function. There'll be another term. There'll be 2 terms. Right? And I'm going to give you one more tip, which is that if you calculate the average value of k squared for that distribution, it's infinite. You should find that disturbing when you get to it. I'm just warning you. There's going to be infinite.
How is that?
What?
Yeah, that's disturbing.
Yeah.
I don't even have to get to it. I just find that disturbing now.
It's really easy to show that it's I was going to actually even add a little question to the problem, but then I eliminated it at the last minute, which was, does this disturb you?
You do have that in there.
Do I? Oh.
Do you find it surprising?
Yeah, you do.
Oh, do you? Yeah, okay, I left it in then. I thought I took it out.
Are you surprised? If so, why?
Yeah.
And then.
It looks like that.
And then you
It's
have.
not finite.
And then.
What?
And then the width, full width.
Can you tell us once we solve that?
Oh, yeah. Then there's one other thing. This function, as I told you, looks something like this. I'll center it. That's supposed to be symmetric. I didn't draw it correctly. But it looks something like this with an envelope that looks like that. Okay? It's the single slit diffraction pattern
Oh, wait.
that you get here. So anyway, it looks like that. What I want you to determine is the full width and half maximum of the envelope. Right. And the envelope just looks like 1 over k minus k naught a. Well, there's a sign function on top, so you find out when k minus k naught a drops to 1/2. The actual value of 1/2. It's infinite at 0. But the sign function limits it, so it's only got a value of 1. And then it's good enough, as far as I'm concerned, to figure out when k minus k naught a. 1 over k minus k naught a is equal to 1/2. At that point, you've got the half width, half maximum, and the full width, half maximum is that much. Did I actually give you a particular wavelength?
Yes,
You did
Dr.
Kelly
Wright.
Green.
Kelly Green, yeah. And what I think you're going to find out, I'm not actually positive because I didn't do it myself, is that the wavelength spread that will be described will go from mid-blue, let's say 480 nanometers, no, probably even shorter, violet, indigo,
Something like that.
up to yellow. So we'll no longer, just chopping it off on the two sides. You start out with a wave which is green, and just by chopping it off, you turn it into a wave which is pastel. Has a lot more wavelengths. It's almost white. Which I think is really cool. So I think actually, if it's all right with you, because then you can object, I'm going to run downstairs and click submit, because it seems as though I wrote that note and then failed to submit it to you. If nobody got it, then I sent
Well,
it to
we
you.
only have 2 data points. It's possible that we just both haven't received yet.
I haven't gotten it.
And neither have I.
Okay, that's more than 2. No, where'd he go?
Well, you should have said something.
Good.
Nice. Perfectly reasonable that.
You've got T1, they assume this, and it's not equal, and then I don't know how they get it.